Hello, everybody, and thank you for joining us for today's webinar. We're going to be having a couple of question and answer periods throughout the event. You're welcome to put your questions into the chat window, and our speakers will answer them when we stop for questions. At the end of today's presentation, we're going to have a quick poll, and we'd appreciate your feedback on how we did today. So I'd like to start us off by introducing our two speakers, Mr. John DeYoung and Brandon Peterson. As the owner of Artex Barn Solutions and several dairy equipment dealerships, John has a unique insight into the needs of today's farmers. His experience in large-scale dairy design has inspired him to branch out into other areas, leading him to his current role as president of Hydro Green. Brandon has 12 years of experience in the traditional feed industry and knows the challenges farmers will face today and in the future. As the business development manager for Hydro Green, he's passionate about working with farmers on creative solutions that meet the needs of evolving industry. So after that, I'll pass this over to Brandon, and thank you everyone for joining us.
Well, thank you, Karen. It's really an honor to be here to partner with Artex Barns on this webinar and really just have a chance to start a discussion or dialogue about what the future of nutrition might look like, or at least from where we sit with the information that we have as a company, what do we see coming down the pipeline and what are we doing? So with that, we're going to kind of set the stage here. Really, what are the nutritional goals of a dairy? For that matter, this broad subject right here really works great for all species. First of all, we have to meet the protein, energy, and phosphorus needs of that animal, whether it's a milk cow or developing heifer, a dry cow, really a nursing calf. We've got to meet protein, energy, and phosphorus is our first nutritional goal. First we have to meet maintenance, then we have to meet production, and then finally we'll have reproduction. And that doesn't matter what species it is. The unique thing is those are the three most expensive requirements to meet. We definitely have individual ingredients that might cost more than one or the other, but on a macro level, meeting those three requirements is the most expensive thing that we do on our dairy. Let's look a little bit. This is a chart of milk production per cow here in the United States. The biggest thing here to discuss or to put in our minds is the angle of that curve. What's that line doing? We go from 2010 to 2019, we're seeing about an 11% increase in milk production. Now, the unique thing, it doesn't matter what country we put up. That curve is almost identical. Some places it might be 12, 13, 14% increase. Some places it might be an 8 or 9% increase. But over 10 years, it's doing that. Now, beyond that, it doesn't matter if we're talking about milk. If you look at hot carcass weights in fed cattle, meat production, that curve is going to be very similar. Like I said, it might be a percent or two different, but the angle of that curve is going to be almost the same. And furthermore, it doesn't matter what country we put up. The curve is almost there. So each and every year, we need to produce, it doesn't matter if we're expanding our operations, so we need more protein, energy, and phosphorus, and everything else, the micronutrients, to meet the demands of a growing herd, or if it's using genetics, management, facilities, whatever it is, we have greater demands each and every day or each and every year for our operations, even without expanding. So feed production, what do we have control of? Under the conditions that prevail, poor quality feed, really low digestibility and low nutritive value is one of the major factors limiting dairy production. And that's all production and all reproduction. You know, and we can say that about almost any species. If you look at what you actually grow on your farm and the amount of nutrition it provides in that diet versus what you buy, or in some cases, what you can't grow on your farm, there's a big gap. And it gets expensive to do those things. So what can you produce on farm and what arrives on trucks? I was on a dairy earlier this week, about 4,500 cows. They had 12 different commodities in their commodity bays. I think 10 of those 12 were trucked onto the farm. They had 3 piles of silage and 3 different hay piles or forage piles they were pulling from. So when you look at all of that, how do we make a ration that fits the needs of our animals with genetic changes, production changes, and environmental changes, both from the cow standpoint and the requirements put on us by the states and the governments. The environmental changes is one of the biggest things that we're going to explore or going to unpack here a little bit. So some of the challenges, this is going to be really easy for everyone to get. Current challenges that we have with high quality feed production: drought, little to no growth, high nitrates, snow, ice, really winter. A lot of places can only grow one crop per year. The unique thing or the weird thing about it is places that can grow two crops often don't have the water, or they struggle to have access to water. They're buying water rights. It won't rain. They're in the drought category. And then what does moisture do to feed quality and feed stability? Floods and hails, other disasters, water rights, water availability. Why can't we often produce high quality feed ingredients that are consistent? We need consistent feed to keep these cows on a high producing plane. Also, consumers are changing the way we produce food. So the regulations, restrictions, if you look at Europe and other places, we can't use GMOs anymore. So it's really hard for them to use soybean meal. The consumers are voting with their dollars more and more. They want their animals raised in a certain fashion, with certain ingredients or without the presence of certain ingredients or additives. And then there's a greater push all the time to be sustainable in what we produce and how we produce it. So what we're talking about today is going to be fodder. It's not a new idea by any means. It's been around since at least the 1600s. But at that time it was done, and even till today, it was done in trays with limited controls, and it was extremely labor intense. Every single day you had to seed those trays and harvest those trays, wash them down, carry the feed to wherever you were going. But it was a high labor effort. So currently the dairies and a lot of other operations, they love the feed, they love fodder, but they hate the labor with it. So the process needed refinement. This used to be a one-size-fits-all approach. But someone would pull on your yard in the past and say, hey, I've got this system for you. It's a fodder system. You go seed to feed in 6 days or 7 days or 8 days or 9 days, or whatever their system required. And they would say, just feed all of this that you can. This is a magic ingredient. It's going to do everything you want. Well, it's not the case. It's an amazing ingredient, but it's just one ingredient in part of a well-balanced diet. So hydrogreen quality nutrition. So what is it? What is fodder? What are we growing? It's up to 95% digestible. It's got natural enzymes that aid in the overall digestion. So if you have a seed, if my fist is a seed, say it's a barley seed or a wheat seed, which would be the two most common seeds that we germinate, but you have this dry seed right here. Doesn't matter if we put it on our system or we put it in the ground and try to grow it. When it gets wet, the hydrolytic enzymes are going to open up that seed, start the digestion process of that starch, and convert most of that starch into sugars. Those natural enzymes that are digesting that seed are still alive and active at day 6 when we harvest our feed. Those enzymes are going to go in the rumen of your cow. They're going to help have an additive effect to the digestion of all of the ingredients that you feed there. So you're going to get some overall increase in digestive efficiencies. This feed that we produce is high in energy, it's a high quality protein, and it's high in phosphorus. The process of germination will also naturally chelate the minerals. So where we're targeting these diets, especially the milk cow diets, is about 20 to 25% of the ration dry matter. But it takes balancing that ration, looking at all of your ingredients from a cost standpoint, and making a total of a balanced ration. So anywhere from 10 to 25% we've seen in the milk cow diets that we've done so far. So what is it? What's the nutrition of it? Now this is average. If you start with average seed, this is what you're going to get. Now everyone knows that the seed you put in there can have a wide range. So if you start with good seed that's about 16% protein, you're going to end up with a feed that's about 18 to 18.5% protein. You have about an 85 NEL. It's going to be 30 to 32% sugar, about 0.42% phosphorus, 20% NDF, and about 23% dry matter using wheat, or a little bit more. We use barley, we get dry matter that's about 17 to 18%. We can grow wheat, barley, most seed blends. We've done field peas, alfalfa, oats, you name it is the unique thing. You can grow a lot of different crops or a lot of different seed blends. So for a dairy cattle, the fodder itself is a great fit. It's an extremely important ingredient in a well-balanced diet. But just remember that it is an ingredient, not the ingredient. There's almost no waste or shrink. When you put it in a pile, when it comes off of our system, it falls on a conveyor and it goes either right into the mixer wagon or into a commodity bay, and there's almost no waste or shrink in that process. It's feed on demand, nutrition on demand. And with the moisture in it, it's a great ration conditioner for dry, dusty diets, to help diets stay in mix by adding that moisture in there. It's a high quality and consistent nutrition on demand. So in summary, to summarize the nutrition here, we go seed to feed in 6 days. This process converts starch to sugar. We go from a grain to a highly digestible forage. So the neat thing is your grain or your seed, your parent seed, is about a 62 to 65% digestible. When we sprout it or germinate it and grow it for 6 days, we end up with a feed that's about 95% digestible. We're going to see about a 2.5 to 3% increase in protein. It's almost an identical energy profile to the parent seed. So we're seeing very little, if any energy loss in this process. The neat thing about this so when you convert all that starch into sugar, you're going to reduce the metabolic stress of that animal by lowering the starch load in the rumen or in the stomach if it's a simple stomach animal, which really leads to improved health in a lot of different animals. So we're going to take a quick pause for 1 or 2 questions. Karen, do we have any questions right now?
At this point, I don't see anything. If anyone has a question and wants to answer it now, I'll give a few seconds here and we can move on if not.
Okay. You can, we've got a couple more spots for questions coming up. So if anyone has any questions, I believe it's probably a little different on my end, but I believe there's a spot on the bottom of the screen that you guys can type your questions in and try to get them answered while we're here today.
Why don't we move on? Yes.
What's that, Karen?
I was saying, why don't we move on?
Perfect. I'm ready. So the unique thing is, so we've been working with this project for a long time now. Here we are in the testing and proving section. So these are some of the things that our customers see and that we see in other herds and other regions that are feeding fodder. We're seeing some higher pregnancy rates, some lower dry matter intakes or increased feed efficiencies. We're seeing increased milk production. We're seeing an improved animal health or herd health and improved butter fat. So how are we going to test it? How are we going to prove it? How are we going to collect the data? So here on the screen is a picture that we're doing for an 800 cow dairy, or we're going to feed 800 cows, I guess I should say. This system, as you can see, the buildings run top to bottom on your screen there. The picture here has 18 systems. We're going to start with 14 systems in this building. There's seed bins on the bottom right-hand corner. There's a conveyor that goes across the bottom, and there's an environmental wall on the north side where we'll have heating and cooling and dehumidification on the top of the screen. The system itself, putting the 14 systems in, will produce about 67,000 pounds of feed or 30,000 kilograms every single day, 365 days a year. It's going to produce about 15,000 pounds of dry matter or about 7,000 kilograms of dry matter each and every day. This dry matter would replace about 300 acres of corn silage or 121 hectares. The unique thing about that, within this footprint, if we replace those 300 acres, we're going to have more energy in that feed, and we're going to have over twice the protein that same corn silage would produce on 300 acres. So the footprint is about 234 feet long and 80 feet wide, which is about 71 meters long and 24 meters wide. Gives us a total square footage of about 18,000 square feet or 1,700 square meters. And like I said, that compares to about 300 acres or 121 hectares. So the systems themselves are it's weather independent production. We have turnkey solutions available, and we're scalable from 1 to 1,000 systems. So if a guy needs one system, we'll produce in the upwards of 3,500 pounds a day if you use wheat. Here's some smaller scale buildings. Now normally when I do this presentation, I'll play a video, and I apologize for not showing you guys the video. But the problem is when we do the videos here over Zoom, they get kind of choppy and the video quality is poor. So if someone would like to see the video, let Karen or myself know afterwards. We'd be happy to send you a link. There on the bottom of the screen is a picture of our system. It's 6 levels high and 6 sections long. The typical system will harvest there on the left-hand side of the screen, and it'll seed on that side. So it's just a belt. It's going to move back and forth. The neat thing is it moves once every 6 days for about 24 or 30 minutes. So there's not a lot of maintenance, not a lot of wear and tear. It's fully automated with just the push of a button on a touchscreen computer. So sustainability and consumer demands. How do we meet the expectations placed on us as dairymen or livestock producers? Where have we been? Where are we going? You guys think back to even 10 years ago. I can remember 2010 on my own operation, and it's so different than what we are at today. Where have we gone and where are we going? Now with fodder production, we're going to see reduced feed miles. We're not burning diesel fuel to harvest and store the feed. The neat thing is we can be non-GMO, organic, grass-fed, any number of labels basically on day one. And then we have a huge water savings over traditional crops. So you say huge water savings, what does that mean? So this chart or this picture shows us how many gallons of water it takes to produce just 1 pound of dry matter. So you look at the small raindrop where hydrogreen or the fodder is, it takes about 1.3 gallons of water to produce 1 pound of dry matter from hydrogreen. If we're going to do corn silage, it takes about 26 gallons to produce 1 pound of dry matter. And alfalfa is the one that uses the most here, about 45 gallons of water to produce 1 pound of dry matter. Now, if you guys are watching from somewhere else, I apologize for not converting that to liters, but it's the scale of the graph or the picture there that is important and not necessarily the numbers in that case. So vertical farming is one possible solution. We have on-farm nutrition control, it's scalable. We have consistent production, both in quality and in quantity. The fodder itself will be the most nutrient-dense feed that you can raise on your farm without further processing. I mean, I guess you could argue that I can raise DDGs or dried distillers grains on my farm, but you need further processing. When we look at those commodity bays on that dairy I talked about earlier, not very many of those ingredients in that bay were raised there on the farm, thus losing the control and obviously at an added cost or added margin to bring that feed from somewhere else for someone else to handle it. So we say fodder will be the most nutrient-dense feed that you can raise on your farm without further processing, both in terms of protein, energy, and phosphorus, which we started talking about today, how those are the most expensive macronutrients that you're going to get on your farm. So really we're talking about custom nutrition with predictable results. The idea that we're looking at is putting you guys back in control, taking out risk. Really our #1 risk in feed production ends up being the weather. So hydrogreen is putting you in control of your farm, putting you in control of your feed, your farm, and your future. Do we have any questions right now, Karen?
Yes, we have 2. So the first question was, have you seen any palatability difference between a group of cows fed with fodder versus one that was not? From a refusal stem, oh wait, that's a separate question, I think.
Okay. You said palatability?
Yes.
So yeah, this feed is extremely palatable. I mean, if you remember a long time ago in the dairy industry, almost every farm fed fresh grass silage in the summer. The problem was it was in the summer. And then as that grass grew every day, more lignin, it lignified further and became less digestible. So your target was always moving. Between the moisture in the feed and the sugars that are in the feed, It's extremely palatable. It's highly accepted. When we look at feedlots or other places, and really it fits for the dairies too, as more and more dairies are shipping their heifers off farm to be developed. The palatability and the acceptability to start animals on it, regardless of the species, is extremely high, and it might be the easiest feed to start an animal on.
Perfect. The second question is, from a refusal standpoint of view, intake and speed quantity.
So yeah, so that's really part of our dry matter limits. And those are some of the things we're exploring in greater detail with some of these, like that 800 cow dairy we put up there, and some of the other projects that we're working on right now. But really some of those dry matter limits are because we get the ration too wet, and these cows, whether they be milk cows, lactating cows, dry cows, they could be a beef cow for all I care. At some point, they can't eat enough pounds to meet their dry matter requirements. So the water in the feed is a huge advantage from a mixability, palatability, dust removal standpoint, but it's also our nemesis when we get these rations too wet. So we need to work with your dairy nutritionist to help figure some of these answers out, how it fits on your operation.
All right. Have you installed this technology in any robotic dairies?
Have we? There are a couple. Actually, yes. So that's a great. Actually, that's an amazing segue question here to our next presenter. And I'm going to answer that question and introduce John at the same time. So our next presenter is Mr. John DeYoung. He's the Chief Design Officer at Cubic Farms, the owner of Artex Barns, and he's the president of Hydrogreen Global and a member of Global Dairy Farmers since 2008. Now, the neat thing about John DeYoung, he bought our first Hydrogreen systems ever. He put them at the Eco Dairy in Canada almost 4 years ago now. Since then, the Eco Dairy has come back and purchased 2 more systems. And John has a robotic dairy up there. It would be one of the places that we have them at, a robotic dairy. So that's a great question, and I think it's one that maybe John can elaborate on just a little bit more. I'm ready for you, John.
I think what we'll do is we'll save the rest of the questions to the end, and we'll go from there.
Are you ducking yourself out of answering a question, Brandon?
I'm ready to go if we need to. I don't care.
No, it's an honor to be here with everyone. It's great to see so many people engaging from so many countries. So welcome. And thanks for taking the time out of your busy schedules to join us today. I see we have people from at least 10 or 12 countries, so it's exciting. So thank you. A lot of you on this group, the participants, I do know you. And for those of you that know me, I've been blessed the last 25 years to be able to be exploring different countries in the dairy sector, and been able to work with food companies, large and small dairy producers, different vendors, different brands of milking equipment. And it's been a lot of fun because it's helped me try to carve out a piece of our role. What is our role as Artex and our group of companies in the future of dairy farming? As Brandon said, I'm a partner to Bakerview Eco Dairy up here in Canada. We built it in 2008. One robot, a small scale anaerobic digester, nutrient recovery system. So we've been playing around with the word sustainability for a long, long time now. Also mention I'm a member of Global Dairy Farmers since 2008. Every year we go on a journey. We've been to Vietnam and Thailand. We've been to different parts of Europe. We've been to China, Russia, and start to see the challenges and the struggles each of these regions have. Up here in Canada, where I live, and I see there's a few Canadian dairy farmers, Tony in particular, are with us. Land is expensive. You go to California, land is expensive, but we also don't have water. So the regions change, and they're very, very diverse. So what I wanted to show you here in particular is just one slide today of sort of 2 projects. We're doing a project similar to this in the Midwest, and this project here is in Eastern Europe. And I want to just walk you through what we're planning on doing and we can open up discussions if there's any further questions with regards to the topics I discuss here. The word sustainability, carbon footprint and such is really, really becoming part of our, call it our world. In fact, there's at least 10 projects I know of that are in Kansas, New Mexico, Texas, California, where digester companies are coming in, partnering with the dairy farmer, and they're putting in massive digester projects. They're providing the capital, and they're working on putting gas in the pipeline and getting carbon credits. So we're taking open lot dairies, putting them in freestall barns, and their carbon impact is reduced. So this digester process, and the reason why this is happening is if you go on the internet and do some surfing, you can see the negative impact that we as an industry are being accused of with the methane gas extraction and the negative carbon footprint. And there's people that believe in this industry that we spend a lot of time with, that carbon footprint is going to be as important as the milk that we produce in the next coming 5 and 10 years, certainly the next generation. So this dairy, as I walk you around, is designed to be and will be constructed as a net, the word is the negative carbon footprint will be negative. It's a negative carbon footprint dairy farm. You'll see there's no lagoon here. You'll also see that there's a milk processing plant, and I'll just use my mouse here to walk you through. So this particular site will have its own processing plant. This particular one will have 2 100 stall rotaries here in this building, 2 6,500 cow freestall barns milking between 11,500 cows. This manure will be scraped, and there's a manure processing building here. So we're not going to flush because we can't get the nutrients controlled in a flush facility. You'll also see this is a flat roof facility. I'm not going to get into the design type. It's a flat roof facility because what we're doing in this particular barn is I was involved with a project with a group in Brazil. And they invested with the Wageningen University in the Netherlands to explore the extraction of methane gas out of the air. This technology is now understood and being commercialized, where we can take the air out of the facility, capture the methane gas, okay, take that air through the manure channels, so the scraper manure channels, take that air and basically extract the methane gas. We take the manure, we destratify it, we stratify it, we're able to get the actual nutrients of the manure, which usually lives in the waste stream of the liquids. We're able to get a portion of that into the solids, dry the solids down, pelletize them, and export them off the farm. We then are able to take the liquids, which are now fairly nutrient-free, a little bit high in salt, but we're able to put that into this building here. And as Brandon indicated, we're able to feed about 20% of the ration if we're growing a hydrogreen technology in this building here. What others really interesting is as we burn the methane gas, we create heat. And we're working with a company, it's a long story, but it's a company that we've known for many years, and I didn't know they were doing this work, but they're taking the heat and putting it through a heat recovery system, converting the heat into cooling glycol. This barn here will be an air-conditioned facility using the energy of the methane gas. We will have in this facility, the goal is to have it 14 degrees Celsius at 20% humidity, irregardless of what the temperature is outside. And we start to look at the impact of that anywhere we are in the world. If we can actually create an environment in a freestall barn, and that's the world we've lived in for the last 30 years, the best freestall design, bedding types, all that stuff, which is not for this discussion, but if we're able to give them great quality air, we're able to give them excellent temperature, low humidity, we can get cows performing at a much higher level. Feed them better. What is the genetic potential of these animals if we give them a better environment than we can today? Feed them better, right? So these are some of the things that we're working on that are super, super exciting. But naturally, you're only able to grow on this particular site 20% of the feed. So we still have to feed 80% of the feed. Traditionally, we need land base. We have to grow crops. And That is just the way it is. And then also on this site, we have another phase 2. So we're able to double the production to be able to milk 23,000 cows on one site. And so this is a project that we are exploring. We have received funding to do this, and it will highly likely be built this year. So for us, it's a lot of fun. And my role in this project is to be able to work with the different technologies, the integrators. So those of you that know me realize that one of my passions are working with newly developed companies and new technologies, exploring them, validating them, but then bringing them together. So one of the things that really excite me again is like, how can this technology be integrated into the future of our food production? And again, when we look at the impact of the politics and also our consumers, is when we can actually explore these technologies and make it happen. If we are truly able to give the cows a better life, could treat them better, what does that look like? We can't answer that today, other than the cows in our little dairy are fascinating what's happening. We can't quantify the numbers, so we have to be very careful what we say and don't say. But there is some really interesting data which we're working on, and we've also now entered into an official research project with the University of Guelph, actually, and these other 2 sites that we're going to work on in the industry to help us quantify this, because ultimately this is a capital intensive project, and at the end of the day it has to make the dairyman money or it's not going to happen. So we can't forget the economics of it. So sure, nice stories are wonderful, but we realize it always comes back to economics, and that's what we're in the middle of. So that gives me a little bit of a journey walking around this site, and I'm very happy to answer any questions. If there are some, Karen, you can direct the questions to myself and or Brandon.
We have quite a few. So I think this one is going to be for Brandon. What are the characteristics of the feed grown? Can it be considered as roughage, or is it more like concentrates or something in between?
Great question.
Well, from a nutritional standpoint, it's going to be more. It's going to have properties of both. From an energy value, it's definitely more like a concentrate because we're almost the same energy as the original seed. But we're going to basically look at it in a diet as a roughage. You're going to have an ADF and an NDF very close to corn silage. You're going to have a protein level, like I said. If you just use wheat or barley, you're going to get close to 17.5, 18.5%, depending on the quality of your seed you start with. And we can do other things like add field peas if that's available in your area, or something else in to make a seed blend to grow a feed that's 25% protein. So it's going to be a roughage without a lot of lignin in there, but it's going to have a lot of. We're going to work with it as a roughage most of the time.
Does fodder replace corn silage completely? What we feed at the moment is dry matter and corn silage.
Yep, so it definitely can. You're still going to need some dry scratch somewhere. We see in a lot of operations the ability to go to a lower quality forage to get that, whether it be a straw or a corn stovers or what am I thinking of? Like here in Utah, where I'm giving the talk from, we might use a 3-way hay instead of a high-end alfalfa and a corn silage mix. So in a lot of instances, we're going to provide quite a bit more energy than the corn silage itself, and like I said, probably about double the protein as corn silage. There's a huge opportunity then to take that land, one, if you're buying the corn silage, to just not buy or rent that land, or 2, grow a different crop or change your operation around with that ground that you corn silage on. I mean, those are definitely things we want to work with you on an individual basis and work with your nutritionist. But definitely that is the gist of what some of our guys are doing.
All right. Is there any data on methane production from cows feed the fodder?
I'm not aware of that data being collected at this time. John, would you have any? I think there's some conclusions we can draw, but I'm not aware of that at this time.
Yeah, that's a big topic for discussion, and in the feed world, that is now on the charts for discussion, where in the past it wasn't. So that's part of our research, is trying to identify the differences. So there's a project in the Midwest we're going to be entering into. So it's going to be 2 pens of 400 cows, and put them the same type of lactation dates, put them up against each other and measure these things. Indicators say it should be effective, but it would be irresponsible to talk about what we think it could be. We want the universities to tell us, so that we can make certain the information that we give is credible and verified by a third party. And that's going to be with all the data that we bring to the marketplace. So today, we want to make it clear that what we're talking about here is things that we have to prove, we have to fail, we have to learn and verify. And it's going to take us a bit of time, but the initial findings, like even on our little dairy farm, you know, the grass-fed, we're doing a grass-fed beef program there as well, without feeding any grain. So we're feeding, and on that video clip that you will, everyone will have access to, Karen can send links maybe to all the people that are joining us today. On that video, Bill and I talk a bit about this grass-fed program and how do we get to the AAA without feeding any grain. So there's clearly some animal health changes by using this feed.
So we have 2 more questions, but I'd just like to say that yes, that will be included. We'll be sending out an email with a link to this presentation, and I will include the link to the video that you're speaking of.
Thanks, Karen.
The next question is a bit of a combination. So what is the selling process? How does a typical sale play out? The cost per unit? How big a herd can you feed with a unit? And the supply chain, who manufactures, and are there any issues or delays or issues with the supply chain?
So I think the sales process really ends up being a more of a one-on-one process, where we work with you, your nutritionist, depending upon the size of operation, assuming you have one, where we can take some of your data and put it together with ours and give you a realistic look if this would be a benefit for your operation. And then there's a ability to take tours, see systems in operation, things like that. I don't know if I remember the rest of the question, Karen. I know some of it, go ahead and re-ask the question, Karen.
All right, so how big a herd can you feed with a unit?
From a dairy standpoint, we're looking at herds as probably as small as 60 to 80 cows, all the way up. You can see this project on the screen here. The system itself is really easy to scale once you start with the first one.
And what is the cost per unit?
So the cost per unit is something that we need to explore with each individual customer, just because there's so many, as you guys know, when you're raising a crop or you feed your cows compared to your neighbor's cows, there's so many things that go into each calculation. So depending upon buildings, if you have a building, if we need a building, different things like that is really what we need to help explore together in this process.
All right, I think the last one is who manufactures the units, and are there any delays or issues in the supply chain?
Yep, so we manufacture them right now in South Dakota. We have a brand new, beautiful 21,000 square foot facility where we do that. Really, if a guy needs a building, we've never been able to not meet that. Really 6 to 8 weeks on the short end and 90 days on the long end would be our furthest target. So by the time you get a few things done, we don't foresee delays.
All right. I have one more for you, Brandon, and then I think the next one is going to be for John. So Brandon, can you expand on fodder as a free matter basis? I keep seeing that if you calculate it as a dry matter, it's not worth the cost to feed it.
Great question.
Yeah, that's a great question. So to date, the fodder industry, there is some people doing it on a larger scale with tray systems, but it's very few and far between because of the labor that's involved. So really, if you look into automated systems, I'm going to be willing to say we have the longest track record of doing this. Our system is going to be totally different than a tray system, where we have really nice slope, we get really good drainage, we use both overhead sprinklers and flood irrigation or drip irrigation under the root mat. We're seeing on average about a 24 increase in dry matter in just 6 days, seed to feed. But your dry matter still is a key there in making that cost analysis. You have to get some of that increase in there to really make it worth it for you. And there's a lot of, if you look at the research, there's a lot of data that's been done on tray systems, and they're not getting enough dry matter increase. They're getting a lower dry matter than what we see on a regular basis. So that is 100% correct, that there is some of that data out there, and it really depends on the system. And that's really, doesn't matter if you're planting corn, there's 6 different kinds of planters or more on the market right now, and they all plant your seed just a little bit different with a little bit different variation for their own reason. We have a system that grows feed different than some of the other systems out there, and we're seeing a nice dry matter increase because of it.
Onto that, Brandon, if you don't mind. So up here in Canada, like on our little dairy, we've been trying to learn and play with this. And again, we've come from a customer for a period of time and then realized that this system has a play in the larger dairy industry in this particular conversation. So in January, we acquired the company to help it get to the next phase. So we own the company now. And so one of the things we did is there's another farm here that was feeding about 200 cows with the tray system. And it was really interesting findings though. The health benefits were all there, but on the dry matter, they were not able to get over 15 or 16, and the odd times 17% dry matter. On our system here, and we're a bit dependent on the seed that you buy. We're learning it's really, really important to get certain types of qualified seeds. But we're regularly at 23 to 26% dry matter on this machine. And that's basically, like Brandon talks about, it's got a certain slope, water is able to exit, it comes out much drier. The plant gets better health, better controlled environment. There's a whole bunch of little things that the growing people have identified in order for this thing to be really, really easy to operate. And the tray system, because of the climate control, the trays, the inconsistencies, they would often get mold flare-ups. So for those of you that do research on fodder and some of the container growing in fodder that's been around for a long, long time, there's not one system that the guy talks about this disaster flare-up of molds in there. So we've identified certain types of seed cleaning and growing environments. So this is really a simple system, which is part of why we took the position in the company that we did. As we do more research, others will figure it out, but haven't. It's a very simple, low-cost system traditionally. It's been around for a long time. And like, hey, Brandon's in Utah, and there's what, over 20 farms feeding this stuff in Utah, Brandon? Almost all with a very low-cost, unsophisticated tray system, but they're still getting a lot of the health benefits. So to me, it's really interesting to see how technologies, automation, precision farming, all those things meet together to get these results. So dry matter is a huge one, and we're fully aware of that. And I think another thing too that I might want to share with everyone, we're working on a project in Texas right now. I won't say names for confidentiality. A lot of you will know them, but the point is what Brandon talks about, sitting with the nutritionist. We've actually gone through his high group, his mid group, his low group. We've built the rations with their nutritionists and have incorporated it with them, and really have discovered what are the economic drivers for that particular reason, which is much different than up here in Canada. So that's a real fun process, because we will help learn. This is what we're looking at. And I think Fernando's with us on this call as well. We need to learn what are the benefits, and to be completely transparent to everyone, we have to get to that next level. We're very close. We're really getting some excellent indicators. But as Mr. Jones would say, Gordy, a good friend of ours, John, it's just math. And he's actually exactly right. And that math calculation is in progress.
Perfect. So we have one question left. I'm going to switch to our last screen and launch the poll. But John, while I do that, are you able to explain how cubic farms and hydrogreen fit together?
Yeah, I will. Thank you. Good question. So 4.5 years ago, I was called by the largest shareholders of Cubic, friends of ours, and I came in to help develop the machines and so on and so forth, move manufacturing overseas, and those are some of the things that we do and industrialize the machinery. And as we spent time with Cubic Farm, remember, on our little dairy, and I'm still John the cow guy. So no matter where I go, I'm John the cow guy. So when I was working with Cubic Farms, we were still continuing to look at, we're working with Artex and like Karen showing Gordy Jones there, a very good friend, dear friend for many, many years. So we're still working in this dairy space, and we have this huge level of interest in the feeding technology. Controlled environment agriculture has a place in the future. How it performs determines what place it has in the future. So when we went into Cubic Farms, it started like this. I got a phone call, John, I keep hearing you're the guy to help us develop this business. And the answer was, well, I'm kind of busy, but now you're gonna wanna see this. So when I was brought into Cubic Farms, I started to learn about shelf space. I started to learn about human food, lettuce, basil, microgreens, and all that fun stuff. And I sensed there was a nice diversification play to our current company portfolio. So I got involved, become a shareholder and stuff of Cubic Farms. And then as we got into the marketplace, we realized when we go to the Middle East, like Indonesia, Vietnam, Thailand, Pakistan, I see there's some people from those regions on here as well. Feeding ourselves as people to dairy farming is feeding people. So there's a natural progression. So we have to feed the cows to help them create dairy products to help feed us. So the Cubic Farms is again, it's leafy greens and basils, microgreens. And when we go to the Middle East or we go to those countries, every time we start talking about feeding people, that's great, but do you have any technology to feed our cows? So inside the Cubic Farms, we were developing different tray mechanisms to grow wheatgrasses and things like that. And then it was really fascinating, the journey. It's like, well, these machines will do this, but it's not the right technology to do large scale animal feed. But we kept getting asked those questions. And then because of our relationship, I got to meet the people 4 years ago at HydroGreen, help them develop the machinery further as well. And they're amazing people. So we just decided to kind of partner together as a group so that we're able to offer both human food in a controlled environment world and animal feed. So that's why Cubic Farms merged, became partners with HydroGreen to give them the capitalization and the resources and the connections in the marketplace, because they're so similar, especially when we go outside of Canada and the US to companies like Qatar, where we just did a big dairy, and other regions, because there's a lot of synergies of working together. Hope that answered your question.
We actually have another question. So how much fodder do you feed per dairy cow on a wet basis?
So that answer is going to vary, and that's probably why we didn't give a direct answer. But if you just look at 20% of the dry matter, if you have a high producing cow eating as many as 60 pounds of dry matter, that 20% converts to about 50 or 52 pounds. So a real simple answer is we're going to say 40 to 50 pounds, but that's something we need to work with. Our nutrition team needs to work with your nutrition team and discover where that really fits in your operation.
And to add to that, Brandon, I think what we're also uncovering is in a sophisticated dairy farm, we're going to call it a sophisticated dairy farm that has different rations for different groups. Our team is really saying which animals are going to benefit from eating this. It's not likely we're going to feed all your animals this product, because it has to make economic sense on your dairy farm. So that's our responsibility, is working, again, getting results and data, saying maybe you're only going to feed this to your cows from fresh to breeding. Maybe it's just your high group. Maybe the dry cows are going to get a huge benefit from it. So that's, I think, some of the time that we need is to really explore, because feeding it to everybody is not what we think is going to happen. It's going to be a portion of your herd. And I think that will also vary from one herd to the other based on the other products they have available to feed their animals.
Excellent.
I think you're right, John. And really that key is what other products you have. Because when we step into a a Western cow-calf or feedlot operation, and their number one resource is dry, low-quality forage, it's a totally different discussion with their nutrition team. So it's really, as much as we love to give good, direct answers, it really is an exploration process that we do together.
Perfect. Thank you, gentlemen. It looks like that's the last of our questions. So while you're filling out the poll, I'd just like to highlight that June 26th, we have our next presentation. It's the All Seasons Hybrid Ventilation Barn by Dr. Gordy Jones. We're really excited to have him on board. So you have two options. You can visit our website at artexbarn.com/upcoming events to learn more, or you can use your phone and scan the QR code that's sitting here, and you'll be taken to the webinar page where you'll learn a little bit more and you can register. So thank you again, gentlemen.
Our pleasure. Thanks for joining us, everyone. Have an amazing day, whether it's morning, afternoon, or night, wherever you are.